Hello, everyone. So, as Kira mentioned, I'm Sam Moelius. I work for a company called Trilobits. We perform security assessments. We try to develop tools to help us with those security assessments, and Dylint is one such tool that we've developed. So Dylint allows you to run Rust lints from dynamic libraries, and as such, what I'll be talking about today is the following. I'll give an overview of Rust linting generally. Then I'll talk about 5 categories of lints that I think Dylint is good for. Normally, when you install Dylint, you install 2 commands, cargo Dylint and Dylint link. I'll explain what each of these are and how they work. Then we'll go into one Dylint lint in some detail, and that is called try EuroRust. If you want to learn more, I'll give some resources toward the end, and then finally, I'll discuss future work for Dylint. So if you have a laptop open right now, I'd like to invite you to install cargo Dylint and Dylint link. Later on during the presentation, I'll give you some commands you can run which use these should you choose to. But again, only if you choose to. Okay. So first, I'm going to give an overview of Rust linting at a high level. So when we talk about a lint, what are we talking about? So according to Wikipedia, a lint or linter is a static code analysis tool used to flag programming errors, bugs, stylistic errors, and suspicious constructs. And so then, what are some Rust linters that we know of? So the Rust compiler itself actually has several lints built into it. So if you've ever gotten a warning about unreachable code or unused imports, or there are many others, these are actually lints that are built into the Rust compiler that are flagging your code. And then when you install the Rust compiler with, say, Rust up, you actually install alongside of it another tool called Clippy. And Clippy is self-described as a collection of lints to catch common mistakes and improve your Rust code. And then, of course, the subject of this talk is our tool, Dylint. And what Dylint does is it runs lints from dynamic libraries named by the user. And as such, it allows developers to maintain their own personal lint collections. I want to make this point before proceeding, and that is that a Rust lint is a Rust lint is a Rust lint. And what I mean by this is the following. I will use the phrase a Dylint lint, but when I say a Dylint lint, I merely mean a Rust lint in a Dylint library. But a Dylint lint or a Rust compiler lint or a cargo Clippy lint, these all use the same Rust compiler APIs, and in that sense, none are fundamentally different, and moving from any one context to the other requires only minor changes. I should emphasize that the Rust compiler APIs that each of these use is unstable. There is an attempt to impose a stable API on top of the Rust compiler APIs. This project is called Marker, and it's due largely to Fred Stolt of the Clippy team. And if this is something that interests you, I recommend that you check it out. So when I say that the Rust compiler APIs are unstable, what do I mean? I mean that they can change from one day to the next. And here is a specific example. So the compiler APIs, the Rust toolchains have names like nightly 2024-0304, nightly 2024-0305. And on this particular day in early March, a Rust compiler developer decided that a field called parse session within a struct called format context would be better off if it were named psess. And from that day forward, that field was then called psess. And the point here is, if you were using this field as Dylint was, and you were relying on a nightly version of the toolchain before March 5th, then you upgraded to a version after March 5th, then your code broke, and you had to be willing to adapt to this and make appropriate changes. So I want to say a little bit more about how the linting process works in a pictorial form. So on the left side of the diagram here, you have Clippy, and on the center of the diagram here, you have Dylint. Okay, so first, Clippy is actually 2 binaries. There's the cargo Clippy command, and when you run that command, it actually runs a second binary, which is called Clippy driver. And Clippy driver you can think of as a wrapper around the Rust compiler. And the reason why I say that is because Clippy driver links against the shared library called rustc driver. And rustc driver is actually where all of the core Rust compiler logic lives. And so what Clippy driver actually does is it says to rustc driver, when you run the lints that you would normally run, would you please, in addition, run these several other hundred lints, which are part of Clippy driver. Dylint works similarly. You run the cargo Dylint command from the command line. Cargo Dylint launches a second binary called Dylint driver, which also wraps the Rust compiler in the sense that it dynamically links against Rust C driver. And Dylint driver loads the dynamic libraries that the user has named on the command line and says to Rust C driver, would you please, in addition to running the lints that you would normally run these lints within these dynamic libraries that I have loaded. I want to talk a little bit about the stages of a compiled program. So of course, there is your program source text. And then the first major thing that gets lowered into is what's called the abstract syntax tree, or AST. In the abstract syntax tree, comments and white space have been removed, but major syntactic constructs have been identified. And when I say major syntactic constructs, I mean things like functions, statements, items, what have you. Then there's another layer below that, and that is called high-level intermediate representation, or HIR. HIR still closely resembles the structure of your source program. However, in the HIR, names have been resolved and types have been checked, and some other analyses have been performed as well. So with that in mind, there are 3 types of lints, and they're called pre-expansion, early, and late. Pre-expansion and early run on the AST, late runs on the HIR. The difference between pre-expansion and early is when they run relative to macro expansion. Pre-expansion runs before macros have been expanded, early runs after macros have been expanded. And late runs on the HIR, therefore late lints have access to name resolution and the types of various objects. This is an opinion, but I think it is a widely held opinion, so I'm going to share it. When starting a new lint, you nearly always want a late lint. And the argument for this is the following. There will come some point in time where your lint exhibits a false positive. You're going to want to eliminate that false positive, and the only sensible way to do it will be to check how some name resolves or check the type of some object, and that information will be available to you only if you have a late lint and not if you have a pre-expansion or an early lint. So as I mentioned, I'm going to discuss 5 categories of lints that I think Dylint is good for. And so to motivate this, I am frequently posed with the following question. Sam, I have an idea for a lint, but why would I put that in the Dylint library? Why would I not just instead submit a pull request to Clippy? And this is a perfectly valid question. So here are 5 types of lints that might be better suited for a Dylint library than a Clippy pull request. So 1, Clippy has a semi-strict policy of not linting third-party APIs. So if your lint idea would involve some popular third-party crate like CERD or Tokayo or what have you, there's a good chance that it would not be accepted if it were submitted as a Clippy PR. Second, Clippy maintainers are volunteers. So if your idea is obscure or exceedingly complex, you might just not submit it as a PR just because you don't want to dump this code on the Clippy maintainer. So you might do this out of goodwill, in other words. Third, your idea might be specific to your project. So Clippy has lints that are specific to Clippy. Dylint has lints that are specific to Dylint. You might have an idea that only makes sense for your source code, and therefore it might not make sense to submit it as a Clippy PR. Your idea might have a high false positive rate. So I hope I'm not about to offend anybody. When Clippy produces a false positive, people will lose their minds. And so in order to save another 100 issues from getting opened on the Clippy repository, you might just keep your lint to yourself for that reason. And last but not least, you might just want to keep your idea secret. You might not want to share it with the world, and that would be yet another reason to put your lint into a Dylint library. So as I mentioned, when you install Dylint, you normally install 2 commands, cargo Dylint and Dylint link. So now let me explain what these are and what they do. So cargo Dylint is a cargo command. It's the way you normally interact with Dylint libraries. It allows you to run the lints in a library, list the lints in a library, create a new library package, or upgrade a library package to a more recent toolchain, for example. Dylint link builds libraries with file names of a particular form, which, as I'll explain, Dylint expects the libraries to have a particular form, and I'll go into that now. So if you run cargo Dylint my new lint, so this is the command to create a new library package, and you were to, all right, so this will create within the directory you're in a new subdirectory called my new lint, and if you look at that directory structure, it will look as the following. Now, I will go through most of these files later on in the talk, but the part I want to highlight right now is this file config.toml. So just to remind you, a config.toml file within a .cargo subdirectory is a configuration file for cargo. And you can put various things in here, but what we populate it with is what you see within this box here. And what this says is, for any target that is built, so the CFG all means any target here, pass these additional flags to Rust C. And what these additional flags say to do is use Dylint link as the linker. Okay, so now let me explain why we do this. So to go back to this diagram for a moment. So as I've mentioned repeatedly at this point, the Rust APIs are unstable and can change from one day to the next. And so what that then implies is that each toolchain has its own corresponding Rust C driver. In other words, the APIs can change, so therefore that necessitates that toolchains have different Rust C drivers because there's different code backing those APIs. Similarly, a Dylint driver linked against a Rust C driver, there will be a different one for each toolchain. And similarly, each Dylint library linked against a particular, built for a particular toolchain will be linked against a different Rust C driver. So the point here is that Cargo Dylint isn't handed Dylint driver. It's handed the libraries. But Cargo Dylint hands control off to the Dylint driver. So the problem, and I use this term loosely, is given the libraries, how does Cargo Dylint know which driver to hand control off to? And we solve this problem in the simplest, most low-tech way possible, which is that we require the libraries to include in their file name the toolchain that they were built for. So in particular, we require a library to have a file name of this form here, and here is a specific example on Linux. And to unpack this for you, it breaks down as depicted, and the important part is this right here. So this is the toolchain for which this library was built for. And so by parsing out this file name, Dylint can tell what toolchain what driver this should load this shared library. And I just want to emphasize that if you're using Dylint link as your linker, then what Dylint link will do is it will detect when you're building this shared library, and it will create a copy and insert this toolchain. So the point is, if you have set up Dylint link as your linker, you will never think about this problem because it will always ensure that your libraries have file names of the appropriate form. Okay, so we're going to go through a particular Dylint lint in some detail now, and this is called try EuroRust. You can follow this QR code if you want. It leads to the URL on the slide, and we'll go into that in some detail now. All right, so first, let me motivate the problem that try EuroRust is meant to help with. So maybe you found yourself in a situation like this. You enter some command, and you run it, and it runs to completion, but when it completes with some nondescript error like no such file or directory. If you're anything like me, this is maddening. And why do I say this? So right away, the first thing I want to know is, what file or directory? And what were you trying to do with that file or directory? We're trying to read it, write it. If it was a directory, we're trying to traverse into it. And for that matter, you can't even tell me whether it was a file or a directory. I have to figure that out. So this seems crazy. Now try EuroRust can't prevent other people from doing this to you, but it can help you write code that doesn't do this to other people. So let me explain. So here is the hypothesis for how this problem arises. You have some function, say foo, and it is performing an I/O operation, and that operation could fail. And if the operation fails, the error that is returned is just returned to the caller straight away. Okay, and what makes this somewhat problematic is that you'll notice foo's return type is not EuroRust, it's anyhow result. So foo could return additional information with that error, but it's not. It's just returning the error straight away, and so it's sort of leaving there's sort of a missed opportunity here. What would be better, arguably, would be if the code were not written like this, but if instead, okay, because the return type is anyhow result, foo could, with the result of the call to file open, call with context, and indicate what was happening when this operation potentially failed, thereby to provide more information to the caller of foo. Okay, so if you chose to install Cargo Dylint earlier, and you have a package that you think this might be applicable to, I'd like to invite you to try to run this now. So here would be the command to do it, cargo Dylint --git, and then this is the Dylint URL, and then -- pattern, this is the path to try result within the Dylint repository. Okay, so again, just to unpack this a little bit, this is where on the internet this repository lives, and this is where within that repository cargo Dylint can find the lint. Okay. So now, if you were to clone the Dylint repository and cd into the Dylint examples restriction directory and look at the structure of the try-result subdirectory, it would look like this. Now, you'll notice that this has a very similar structure to what I showed you earlier. The reason why there are fewer files than what I showed you earlier is because try-result is part of a workspace, and so some of the files I showed you earlier appear in superdirectories as part of that workspace. So the thing we're going to look at in some detail is this file lib.rs. So there are 5 major components to this file, and they are the following. So at the top are some Rust features, extern crate declarations, and imports. Then there's an application of this declare late lint macro. After that, there is an implementation of this late lint pass trait. Then there is a definition of this utility function is EuroRust. And then finally, there is a test. So the parts that we are going to go into in some detail are the macro invocation, the trait implementation, and the test. The parts I'm going to largely gloss over are the following. The header information at the top, because this is uninteresting and mostly boilerplate. And then the utility function is EuroRust. So suffice it to say that if you can understand the implementation of this late lint pass trait, then you can understand the implementation of this is EuroRust function. I will, however, say what this function does. So you'll notice that it takes this argument lowercase ty, which is of type capital T, lowercase y. The type capital T, lowercase y, this is a type defined within the Rust compiler, and it is the type of types. And so what is EuroRust does is it tries to answer the question, is lowercase ty, is this the type standard EuroRust? If so, return true, otherwise return false. Okay, so the first part we're going to go into in some detail is the test. So Dylint provides a crate called Dylint testing, and there are several functions within that package, but one of those is called UI test examples. And what this function does is it runs the lint on all of the examples defined within the package. It collects the standard error after running those lints, and then it compares it to an expected standard error, which appears in a file within, alongside the example source code. Okay, so here is a slightly reduced form of the source code for the single example that is within the try-result package. And you'll notice this first example here, this is exactly the function foo I showed you earlier, the problematic case. The second one is the fixed case. So we would not want our lint to flag this case. And then the third case is yet another one we would not want to flag. And so let me explain why. If you compare the definitions of foo and bar, the only way in which they differ is in the return type. So the return type of foo is anyhow result, the return type of bar is EuroRust. Okay, and remember, the type that file I open returns is an EuroRust. So the one thing to note here is that in some sense, there's no way for bar to return additional information. File open returns an EuroRust, bar returns an EuroRust, so there's not much more bar could do than just return that error. Second, this is a case where we're assuming the programmer has done this on purpose. So we could lint and say you should change the return type, but there's a chance that the programmer did this on purpose. And this is a case where we assume they did this on purpose, and we don't warn just to save annoying the user with false positives. Okay. So as I mentioned, what the Dylint testing package will do is it will run the lint, collect the standard error, and compare it to an expected standard error. So that expected standard error appears within this file main.standard error, which appears next to the main.rs file, and it will look like this. And this should look similar to any linting result you've seen when, say, running the Rust compiler or running Clippy on your source code. Okay. So now the next part we're going to go into is the invocation of this Dylint linting macro. So first of all, what does calling this macro do? Under the hood, it declares something called a lint struct. This, again, is another type defined within the Rust compiler, and it prepares that instance of that lint struct to be run as a late lint. So what are the arguments to this macro? So by convention, the first thing is typically a rust.comment, and this describes what the lint does, and this rust.comment gets attached to that lint struct, which is declared by the invocation of this declare late lint macro. And then the remaining three arguments are the following. So the first is the lint name, which in our case is try.EuroRust, then the lint level, which is nearly always worn, and then finally a short description of the lint. And this short description is what appears if, say, someone lists the lints in the library, and this short description is what will appear next to the lint name. Okay, and so the last part of this we're going to unpack is the implementation of this late lint pass trait. So this is where the real meat of your lint lies. This is where its core logic lies. So you can think of a late lint pass as something roughly like a visitor. So there are these various methods like check expr, check body, check item, and what you have to do for your lint is decide which of those it makes sense for your lint to check, and then you implement those appropriate check methods that are appropriate for your lint. So for try.EuroRust, the one that makes sense is check expr, because we want to check each expression in order to determine whether or not this lint should flag. Okay, so then you'll see with, the first part of this check expr implementation is a big if block. The first 4 lines of this if block do the following. They check whether or not the passed in expression is an application of a Rust question mark operator. Now you may ask, why is that 4 lines? Why is it not something simpler like 1 line? And the answer is because in going from the AST to the HAR, and going from the abstract syntax tree to the high-level intermediate representation, Rust has done some desugaring. So that is why, for example, you can see here we're checking the expr kind, and we're checking whether or not it is a match, and checking whether or not the match source is try desugar. And then you'll also notice, for example, on the 4th line, we're checking whether or not this path here is the lang item try trait branch. So in other words, these 4 lines essentially say, is this expr an application of the question mark operator? And most notably, if those 4 lines pass, then this arg here is bound to the expression to which the question mark was applied. And so then in the next 2 lines, we do the following. So we determine the type of arg, and we bind that to a variable called arg_tie. And then here we're calling that utility function I mentioned earlier, is_IO_result, and we're essentially asking, is arg_tie the type standard IO result? If so, proceed. If not, don't. And these last 4 lines do the following. They determine the body from which expr is being returned, and they determine the type of that body and ask, is the type of the body standard IO result? If it is, don't flag. Proceed only if it is not standard IO result. So this is that 3rd case I was mentioning in the example file we were looking at earlier. Again, we're assuming that if the body is returning a standard IO result, that the programmer knows what we're doing, that knows what he or she is doing, and we're not going to flag. Okay, so all of this stuff here, imagine that is now these ellipses. And so if all of that passes, what happens? We call this function span lit and help. And so what does this do? This is what actually generates our warning. And so what are the arguments to this? So we pass the lint name, we pass a span, which determines the portion of the source text that is highlighted. We pass a warning message, and we pass an optional help message. And so if we go back to our expected standard error, how do those things relate to this? So here you can see the warning message. This is the warning message that we passed. Here you see a source location and some highlighted text. These were determined by the span that we passed. And here is the optional help message that we passed. Okay. All right, so if this interests you and you'd like to learn more about linting in general, here are some resources. So first, the Clippy documentation is really good, and in particular, there's a section called Adding a New Lint, and it covers much of the material I just covered, only in different language. Second, Clippy has what's called the author attribute, and what this does is the following. You can take a piece of syntax and you can precede it with the author attribute and then run Clippy. And what Clippy will write to standard out is a sample if block that you can use to match against that syntax. Now, you nearly always have to adjust it, but the bottom line is that sample if block that Clippy produces is a very good starting point, and it saves you having to look up a lot of the things that I covered in the late lint pass implementation I showed you a couple slides ago. And then third, all of these are Rust compiler APIs, and so of course the Rust compiler developer guide is the ultimate reference for any of these things. Now, those references are very likely going to point you to one of the 5 things on this slide, so let me just quickly say what they are. So late context, this is that first argument CX that was the first argument to our checkExpr function, and then one of the functions that you can call on that CX argument is type check results. This was how we got the type of the arg, the thing that was bound to arg, for example. A field on that late context object is something called TCX, and this allows you to get various information about typings of different objects. And then on that TCX field is a method called HAR. HAR returns something called a map. And you can consult the map to determine different information about how nodes within the HAR tree relate. You can, for example, ask for a node's parent or ask for the type of an object that a node represents. And when I say type here, I mean, does the node represent an item? Does it represent an expression? Does it represent a type? What have you. The last bullet on my slide is something called Clippy utils. This is not provided by the Rust compiler. This is very generously provided by the Clippy team, and it's part of the Clippy repo. We use it in Dylint all the time. It is you can think of it as a kind of a layer on top of the Rust compiler APIs, and there's a lot of useful functionality in there, and that is another tool at your disposal. Okay, so I'm just going to spend one more minute talking about future work. So first, lints ought to be easier to write generally. So we have these great resources, but still, it would be nice if it were easier and it weren't such a barrier to newcomers, for example. And so this is something we're looking into, but this is largely an area of experiment. Bringing this down to earth a little bit. I mentioned earlier the case that the Rust compiler APIs are unstable and they can change from one day to the next. The Clippy repo is actually mirrored within the Rust repo, and one of the reasons for this is the following. It's so that if a Rust compiler developer does something that would break Clippy, that Rust compiler developer is forced to fix it on the spot so that Clippy continues to build. The point here is that these tiny fixes for things like changes to field names, they are reflected in Clippy's history. So this then begs the following question. If a maintainer of a Dylint library upgrades their library from one tool chain to another, might it be possible for Dylint to go through Clippy's commit history and infer these tiny little fixes and apply them for that developer automatically, so that this is then less that developer has to apply manually by hand, and thereby reduce the overall burden for developers when they go to upgrade their lints? We have a prototype of this idea and its functionality we hope to provide soon, but it's not quite ready for prime time yet. Here is the URL for the Dylint repository, and this QR code will take you to the Dylint repository. And with that, I thank you for your attention. I'll be happy to answer any questions.